This is Ramya Krishna from MEGB. My roll number is 17241A0371. In this presentation, I would like to explain about two non-ferrous metals, copper and aluminium, their microstructures, their properties, application, and their alloys. Non-ferrous metal contains elements other than iron as a chief constituent. Example: copper, aluminium, lead, manganese, nickel, zinc and titanium. Non-ferrous metals are more costly than ferrous metals. Non-ferrous metals are light in weight, possess high thermal conductivity, high resistance to corrosion, and they are ease of fabrication such as rolling, welding, casting, forging, machining. They are attractable in color also. Now, copper and its alloys. Before going to explain about the copper and its alloys, I would like to show the microstructure of copper. This is the microstructure of copper, which contains copper pyrites. Copper and its alloys. One of the oldest and most widely used non-ferrous metal in the industry. The properties of copper are soft, ductile, malleable, and it can be forged, rolled, and wire drawn. Now, this is in light in weight and also pleasing color, excellent corrosion to resistance, and it possesses high electrical conductivity also. Copper has a melting point of 1083 degrees centigrade. Density 8.9 into 10 power 3 kg per meter cube, Young's modulus 122.5 gigapascal, and tensile strength 220 megapascals, and hardness 80 to 85 Brinell hardness number. Copper is extracted from its copper pyrites. First, the crushing of copper pyrites is done, then it is mixed with water and filtering it, and then air is blown. Roasting process is done, then after that smelting is done. Electrolytic refining. It is done from a solution comprised of sulfuric acid and copper sulfate. On passing the current to anode into the solution, pure copper is deposited on cathode. 99.95% of pure copper is obtained. Applications of copper. They are used as base coating on steel, and various appliances where lightweight with good corrosion resistance is required, and it is used in making alloys such as brass and bronze. Copper alloys: brass, bronze, gunmetal, copper-nickel alloys. Coming to the brass, which is a combination of copper and zinc, we have three different types: alpha brass, beta brass, alpha beta brass. Alpha brass contains less than 20% zinc, beta brass contains 20 to 30% zinc, alpha beta brass contains 30 to 45% zinc. Next we have alpha brass, that is red brass. 85% copper is there and 15 to 20% zinc is present. It is soft, ductile, and high resistance to corrosion. And these red brass is used in electrical conductors, condensers, and heat exchanger tubes. Coming to beta brass, yellow or cartridge brass, which contains 70% copper and 30% zinc, which has good strength, high ductility, and good working properties. Next, these yellow brass is used in radiator gaps, headlight reflector, lamp fixtures, rivets, etc. Coming to alpha beta brass, we have bronze metal, which contains 60% of copper and 40% of zinc, which has high strength and excellent hot working. Bronze metal is used in valves, condenser tubes, nuts, bolts. Coming to bronze, bell bronze, copper has 78% copper is present, 22% tin is present, and it is hard, brittle, and possesses resonance. Bell bronze is used in making bells. And we have a phosphorus bronze. It contains 88% copper, which contains 0.4% phosphorus and 10% tin, and zinc 1%, which has high ductility and high corrosion resistance. Phosphor bronze is used in bearings, pump parts, springs, and screws. Next we have gunmetal, in which we have a lead gunmetal, which contains 85% copper, 5% tin, 2% lead. and it has high strength and used in pressure tightening apparatus like boiler, steam pipe fittings, hydraulic valves systems. Cupronickel. We have monometal which contains 29% copper, which contains 68% nickel, 1.25% iron, manganese, and which possesses high corrosion resistance and good mechanical properties. This monometal is used in chemical and food industries and tanks and steam turbine blades. Now coming to aluminium and its alloys. Before explaining about the aluminium, I would like to show the microstructure. This is the microstructure of aluminium, which contains oxide of aluminium. Aluminium and its alloys. The bluish silvery white metal is the aluminium, and which is one of the most used non-ferrous metal, and the properties of aluminium are light in weight, high thermal and electrical conductivity, excellent corrosion resistance, ductile and malleable, non-toxic, non-magnetic, and a good reflector of light, and which has high tensile strength. And aluminium has a melting point of 600 degrees centigrade, density of 2.70 into 10 power 3 kg per meter cube, and Young's modulus of 70.5 gigapascals and tensile strength of 45 megapascals. Next we have the applications of aluminium. The aluminium is mostly used in the parts of aeroplane, cooking utensils, electric wires, windows, frames, sheets, foils, lampposts, furniture, precision instruments, surgical instruments, etc. Due to its light weight, aluminium castings are pistons grill manufacturings. They are also used in food industries such as storage containers, bakery equipments, lighting fixtures, tanks, drums, pipes, heat exchangers, etc. Aluminium is extracted from its aluminium ore, namely known as bauxite, and the major impurities of the bauxite are oxides of silicon and titanium dioxide. Bauxite actually contains one of a variety of hydrated aluminium oxides, that is Al2O3, H2O. We have aluminium alloys, in which we have aluminium copper alloys, aluminium silicon alloys, aluminium magnesium alloys. Aluminium alloys are also known as LM alloys. So we have in aluminium copper LM11, which contains 95% aluminium, 4.5% copper, good strength after each hardening, shock resisting properties, and susceptible for hot tearing. And this LM11 is used in aircraft and high stressed parts. Aluminium silicon alloys. We have LM6, which contains 88% aluminium and 12% silicon, which has a less shrinkage during solidifications, which is used in castings, mortar, and pump housings. We have aluminium magnesium alloys, LM5, which is also known as magnesium, aluminium 94.5%, magnesium 5%, manganese 0.5%, high resistance to corrosion, good machinability and weldability, and easy to forge. And LM5 find applications in marine applications. LM13 contains aluminium 90% and magnesium 10%, poor castability due to the addition of magnesium, which makes it so strong. And this LM13 is used in forging, extrusion, and architectural work. LM13, which contains 83% aluminium, 12% silicon, and 2.5% nickel, and manganese and copper 1%. Precipitation hardenable alloy and retain its strength, low thermal expansion, and can be easily forged. LM13 is used in piston manufacturing and forging automobile parts. And we have in aluminium copper alloys, we have a duraluminum, which contains 95% aluminium, 4.5% copper, magnesium and manganese 0.5%. And duraluminum find applications in aircraft and high stressed parts. Thank you.